I like to recap doing the same thing to both sides of an equation at higher levels in maths. Here's a bunch of examples. Have a go in your own time. They start easier and get more complicated. I'm going to minus 5 on both sides, which means I do it once to both sides, to each side rather, but I don't do it once to everything. Let's do the next one. Remember, pause the video if you want to have a go in your own time. If I'm multiplying, I do it to everything, so that's 25x plus 50 equals 75. If I'm minusing, that's like minus, it's just like plus, I just do it once to each side. So it'd be 5x plus 10 minus 5, but I save time personally and I tend to just immediately combine it with one of the objects that I can see. If it's divide, you have to do everything, so that'd be x plus 2 equals 3. I'm going to square root, I have to square root the whole thing. No ifs, no buts, I just have to square root everything. So if that had been like 16 plus y plus 3, then I would have had to just include everything inside. But it wasn't, it just looked like that. And you might have whoops. You might have simplified it just to be x equals plus or minus 4, maybe. But that wasn't what I said to do. Well, at least that wasn't what the question said. I'm going to square root both sides. I wonder, some people make a bit of a mistake here. This is square root of 5 squared equals the square root of 4 squared plus 3. You have to square root the whole thing. If you did this, I'll just say that equals 4 plus 3 because I'm square rooting everything. That's wrong because, guess what? 5 isn't equal to 4 plus 3, is it? So that's definitely wrong. Yeah, you have to do the whole thing. Let's do the next one. What I mean by this is I'm just saying square both sides. So there's like that squared equals that squared. So it'd be 1 plus 1, which would have to be in brackets. You have to square the whole thing, equals 2 squared. Let me just write it again neater so you can see what I've done. There we go. Let's do the next one. I'm going to do 7 to the power of each side. I quite like doing logs like this. There is apparently another way of doing logs, which I've literally never learned. Because I remember when I was younger, I just spotted this at an early stage and never bothered learning the other method. These two then just cancel, because they're inverse functions, so x equals 7 to the minus 3. That's why I like to do use that particular way of manipulating both sides of an equation. Oh look, well that's the inverse function of cubed root, so I can just do that. That's just the inverse function of sine x. By the way, this is how I tend to teach a lot of students to solve sine x. So it's not like magic, they then kind of understand that they're dealing with inverse functions. Anyway, because then you can say, well, those two cancel because they're inverse functions, so x equals blah 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 blah. Last one. This is my kind of log thing again. So I quite like when I've got powers and logs, I like to just do this. If I want to get rid of, say, a log in this situation, I do both sides as a power of that letter, because then I can cancel them because they're inverse functions. Which, by the way, I could then solve it, because you might have spotted that and thought, oh, I can solve that now. So p equals 3. By the way, it's not plus or minus 3 because it's cubed, so it retains sign. There we go. Hopefully that was kind of useful. I like to do that as a little recap, especially if I'm dealing with a sort of more advanced student when I first meet them, just to check that they got good ways of rearranging equations.